This lecture introduces linear first-order equations, differential equations, and we're going to talk about a method that you can use to solve some of the linear first-order differential equations, and the method is called variations of parameters. All right, let's talk at what is first order, right? Linear differential equations. So linear first order differential equation are the equations in this form. If y is a dependent variable and t is an independent variable, then this equation here is the form of linear first order differential equation. And you can see this is y prime and this is y. P of t is a function of t and q of t is another function of t. Okay. So if q of t equals to 0, we call this equation is a homogeneous equation. And if q of t is not 0, then the equation here is a non-homogeneous equation. Okay. If y equals to 0 is the trivial solution of the homogeneous equation, and any other solutions is non-trivial solution. So if you can solve somehow, you can solve y equals to 0, so that means y is a trivial solution. Any non-zero solution is non-trivial solutions. Okay. Well, first we want to make sure that we can identify whether a differential equation is linear first order, whether it is a homogeneous or non-homogeneous equation. All right, let's look at the first equation here. So you have an equation t times y prime plus l ty equals to 0, right? And look at the form. The form is y prime plus a functions of t times y equals to a function of t. And this one, because you have t times y prime, maybe you want to transform it by divide everything by t. If t is not 0, then you divide everything by t to get natural log of t over t y equals to 0. Okay. Well, if you look at this equation here, it is a linear first order differential equation. This equation here is p of t in the definitions. 0 is q of t. In this case, q of t equals to 0. That means this equation is a homogeneous equation. All right. Now go to the next equation. Y times y prime equals to 3. If you want to have y prime by itself, you divide both sides by y, where y not to 0. You can only do that when y is not to 0. And at this point right here, this is not linear differential equation because you have 1 over y involved into this equation. So this is not linear. It's a first order, but it's not linear DE. All right, let's go to the next equation. You have y prime minus e to the ty equal to sine of t. Again, we have y prime by itself, right? Y here, and e to the t is a function of t, and sine of t is a function of t. So then, yes, this is a linear first order DE, and this is it q of t is not 0 and non-homogeneous. Okay, I forgot to say that this is a linear first order DE and homogeneous. All right, So if you have functions, right, homogeneous function in this form, then you can use, and this is also a separable equation, because we can move this to the other side, goes to negative pty, right? And then see that we can divide both sides by y, and when y is not 0, right? Y is equal to 0 is an equilibrium solutions. This is when y is not 0. Then you can divide both sides by y to get negative p of t. Okay, so then you can have dy 1 over y dy integrated equals to pt dt. Okay, then eventually you can solve for y, and y will be in this form. It's because if you keep doing this problem, you have ln y equals to the integral of negative pt dt, right? And then y equals to e to the integral of negative pt dt, and then plus c. So this is, if you want to have plus c, so just you find the antiderivative and plus c here. And then again, you can move c, e to the c, e is a constant. So then you can move the c here to the front of c. Okay, this is how you find the solutions for this homogeneous equation. And then you can easily show, using separable equation, you can easily show that the solution for this first linear order differential equations, homogeneous equations, is in this form, where p of t, big P of t here, is the antiderivative of small p of t that we found in this differential equation. All right. So we know how to do that using separable equation. Let's actually try to find the general solution to this differential equation here. Okay. As we remember earlier that we always want to have y prime by itself, so we divide. So when t is not 0, prime ln t over t y equals to 0. Okay. And then I can use separable equation, or I can use this formula. It's up to you, but I would like to use separable equation here. So then I will move this to the other side, negative ln t, t, y. Okay, and this will be equals to y, move y to this side. So this is going to be dy over y equals to natural log of t over t dt. Okay. Well, at this point, we know that the integral of dy is natural log of y. The integral of ln tt is gonna be, you remember that you can use direct substitution in order to find this integral, where u equals to go to natural log of t, then u prime equals to 1 over t, right? And then you can rewrite this integral in terms of in negative of u times u prime, u du, then u is natural log of u du, okay? And then the integral of u du is just equals to u squared over 2, okay, plus c. All right, where u again is natural log of t. So I can rewrite this in terms of natural log of y equals to negative natural log of t squared over 2 plus c. Okay, then my y, so I want to solve for y equals to e to the natural log of t squared over 2 and c. Well, that's how we solve for a homogeneous equation, right, using separable equation. How about when we have a non-homogeneous equation? So non-homogeneous equations are equation in this form. You have y prime, right, plus b of t, y equals to q of t when q of t is not equal to 0. Well, when we consider these equations, we call this equation here the homogeneous equation of this non-homogeneous equation, which is set q of t equals to 0, is a complementary equation. Okay. And now we can find the solution to this equation, to a non-homogeneous equation, in the form of y equals to u times y1, where y1 is a non-trivial solution of the complementary equation, and u will be determined. So that says, in order to solve this non-homogeneous equation, first you want to solve the equation, you want to solve the homogeneous equation. You find y1, where y1 again is not a trivial solution, it's a non-trivial solution of this homogeneous equation. And then once you have y1, then you set y, which is the equation, y, which is the solution to this non-homogeneous equation, right? We're looking for y in terms of y1. So we take y1 times u equals to y, and u will be determined in a moment. And just keep in mind that the method of using the non-trivial solutions of the complementary equation to find the solutions of the homogeneous equation is called the method of variation of parameters. And we will revisit this method in the sections of the second order differential equation. All right, so let's see what we have. So first we consider this homogeneous, non-homogeneous equation, right? You want to solve for this non-homogeneous equation. Okay. Using its complementary equation. So the complementary equations of this equation is y prime plus p of t y equals to 0. Okay, and then we find the solution y1 as the solutions for this complementary equation. Okay, and then the next step is we find we want to find y, right, in terms of y1, and we take u times y1. Okay, again, y here is a solution to this non-homogeneous equation. So if I set y equals to u times y1 as a solution to the non-homogeneous solution equation, then that means y prime, this y here, has to satisfy this equation. equivalently, I will have u times y1 prime equals to pt times u times y1 equals to qt, right? If y here is a solution, then this also true. So u times y1 prime is u prime times y1 plus u times y1 prime plus just p of t times u times y1 equals to q of t. Okay. And if we look at these two terms right here, I can factor u out, and we have y1 prime plus p of t times y1. Okay. And I still have my this term y prime u prime y1 plus this term equals to q of t. Okay. And because y1 is the solution to this homogeneous equation, that means, and this is the homogeneous equation, right? That means this part right here will be equals to 0. And u times 0 is just 0. So what left over is actually just this term, u prime y1 equals to q of t. Then I can solve for u prime equals to q of t divided by y1. And then I can integrate both sides to solve for u. And again, you remember that y1 is a function in terms of t, right? And you solve for u, then you can have u equals to the integral of qt y1 dt. Okay. Once I solve for u, then I can plug u into this equation to solve for y, which is the solution to this non-homogeneous equation. So to summarize all the steps, I listed all the steps right here. Step that will help you to find a solution to a non-homogeneous equation using its complementary equation. All right, so find functions y1, right? And again, y1 here is the solution to the complementary equation. Okay, so for the convenience, take the constant of the integration to be 0. And then you write y equals to u times y1, just to remind us what we're doing, right? And then you take y prime equals to q of t divided by y1, which we found it here, right? How can we use u prime? Q of t divided by y1. And then you integrate both sides to obtain u. So you obtain u from this equation, and you substitute u into this equation to find y, which is the solution to the non-homogeneous equation. Well, in some cases, you would have a non-homogeneous equation in this form, where the coefficients of y prime is not 1. If it's in that case, then you can just divide both sides by this function. So then y prime will be by itself, and need to make sure that this functions here is not 0. All right, let's do the next example. Okay, you can see here you have a non-homogeneous equations. Okay, it's linear, right? All right. So then first we want to find y1. as the solutions to t y prime plus ln t y equals to 0. And again, maybe before we try to find y1, we want to convert this equation y prime is by itself, right? Y prime has the coefficients of 1. And then we can find the solution to the complementary equation. So let's do that first. Here. So this equation, I divide if t is not 0, right? Then I divide both sides by t. I had y prime plus ln t over ty equals to ln t r squared divided by t squared. All right. So then now at this point, I know it's still a non-homogeneous solution and linear. And the next step is I want to find y1 as the solutions to y prime plus ln t over ty equals to 0. Okay. And this is an example that we already found a solution to in this example right here. Okay, and the solution is just imagine that c here equal to 0. So the solution y1 will be e to the negative squared divided by 2. Okay, so I found my y1. Step is, again, I want to remind myself what I'm doing. I set y equals to u times y1. And then I know that u prime equals to q of t divided by y1. What is q of t in this situation? Q of t is this functions here. And this is p of t. Okay. So I would take q of t, natural log of t squared over t squared, divided by this y1, that means it just multiplied to 1 over e to the negative natural log of t squared over 2. Okay, just combine these two together. I will have natural log of t squared divided by t squared e to the natural log of t r squared divided by 2. Well, I found my u prime. Now, in order to find u, to solve for u, I just integrate both sides. So that means u equals to integral of natural log of t squared over t squared times e to the natural log of t squared over 2. This is a square. dt. Again, this is a negative multiplication here. All right, at this point, I don't need to, I don't think we can find the integral, this integral explicitly. So we can just leave it in the integral form. But at least I know what is u, right? And how I could find u. And once I have u, then I can substitute u into this equation in order to find y. So y equals to u times y1, and u is integral of natural log of t squared over t squared times e to the natural log of t squared over 2 dt. This is u, and y1 should be e to the natural log of t squared over 2. I could say that in the real world, most of the time, your solution will be implicit solutions. It's not an explicit solutions. And if you cannot find an explicit integral for this integrations, then this is the solution for your differential equation. And again, this is just a general solution, because as you integrate this here, as you find this integration, you will have a plus c. And later on, you will learn if you have an IVB problem, then you will just integrate this integral from a point, to starting point, to a point that you want to integrate to. Okay, and this is the solution again, and this is an implicit general solution to the equation, to the non-homogeneous equation here. All right, this is how you solve a homogeneous differential equations, right? If it's in the form of a linear first order homogeneous differential equation, you can use either this formula to find the solution, or you can just use separable equations. You consider it as a separable equation to solve for this first order linear first order differential equations. And when you have a non-homogeneous equation, then you can use the solutions of the homogeneous form or the complementary equation in order to find the solution for the non-homogeneous equation following the steps. Okay, once you have y1, then you set y equals to u times y1, and you can find u by solving for u prime equals to qt divided by y1, and you can just integrate both sides to find u. And once you have u, you can just plug u into this equation to find y, which is the solution of the non-homogeneous equation. This is an example of it. And again, in this example, you couldn't find an explicit solution for this differential equation, but it's fine, right? We found y1 explicitly, and we found u in terms in the integral form, and then we can find y by taking u multiplied to y1. And again, this is an implicit general solution to this differential equation right here. Just want to point out that this is u that you found, and this is y1, and this is y.